we live? It's a stupid question. Of course we are. I can see green lights to the left and right. But what are we live for? The hell out of here. I need to do some sorting out here. Got a GameCube, by the way. I didn't mention that earlier, but very excellent sounds going on here. Yeah, maybe I should just super glue that in place. After this stream, I will do that. I have a little brass shim to help the boom. As you can maybe not hear. So it has a cast zinc base, which is okay, but it's powder coated and it's fairly rough. It's not very good for spinning the mic out of the way. So I'll just put a little. It's actually a spring from a door, but it's brass, so it's lower friction than powder coat. But I'll secure that because it just came off, and it's very annoying actually when it does that. Anyway, welcome back. This is the C++ stream for everyone who's interested in watching me struggle through the C++ language. Thought it'd be a great idea to stream this because I'm an idiot, and that's it. You know, it's like a little, you know, a friendly banner of I'm gonna fuck this up so you can fuck it up too, kind of thing, you know. And it's my Twitch page, so I can fuck everything up as much as I like. You can complain, but you can't stop me. Anyway, last time we were doing references and pointers. We did a lot of very interesting and deep learning about references and pointers. Stuff like this is very important. We have the initialization of a pointer p here. We have the editing of the contents of the pointed value. Then we it's not initialization, but it's, what's the other word? Crap, there's so many different words to keep a track of here. Not initialization, because that would require also the creation of the thing, but just changing the value of the pointer rather than the pointer's contents, the actual value of the pointer to null, making it a null pointer, and then trying to access the value that points to returns an error at runtime because you cannot assign a null pointer a value. You can't assign the value of null a new value, essentially, because the pointer points to null rather than a value. Of course, you could change the star p value to back to omega and it would work fine. You could change omega to 9999 if that was your prerogative. Maybe it is, maybe it isn't. Maybe we don't care. But yeah, these are generally fairly short streams in the grand scale of things. You know, I try to keep it within an hour, because doing more than an hour's learning basically ends up in a non-productive state. The brain turns to mush, and the brain turns to mush. So today, what are we doing? Compound type declarations. Oh, goody. It's really stupid that I just keep adding to this. I should I should really just have another file, but it's such a pain to open everything up and do everything again. Big word, big letters dropped to lads previously in the Unreal Engine stream, who may or may not be here right now, for pointing out Visual Studio licensing stuff. And big shout out to Visual Studio for repeatedly screaming at me that I have no license and that I should get a license. You'll see that there is an M in the top right hand corner. It means I'm logged in. It means I have a license. It's a crappy free Visual Studio community license, but it lets me use VS 2019. It lets me write code and it lets me compile it at least. At least I hope it does. Oh my god, I didn't even check. It'll be fine. Be fine. We'll cross that bridge when we get to it. So what is a compound type declaration? Each declarator can relate its variable to the base type differently. If declarations in the same definition. A single definition might define variables of different types. Okay, it's fine. Int I, okay, star P and I, R and I, okay. Is that it? Is that all a compound type declaration is? When you have just a whole bunch of declarations in one line? They all link to each other. They actually here it says it's a common misconception to think that the type modifier star or and applies to all variables defined in a single statement. Part of the problem arises because we can put white space between the type modifier and the name being declared. I do not like that, and I do not like the way Visual Studio applies white space. Why is there yellow all across my CRT? Oh god. Alright, I don't have time to think or fix that. Yes, it puts white space after that and puts the special character, the modifier character, next to the type. But it's good. The star or the and only modifies the item directly proceeding. Very good. Good. Some schmutz on my screen here, it's hard to read. Sorry. Maybe if I flipped it this way. Oh my god, that's so easy to read now. Oh wow. I still want a Kindle. I still want a Paperwhite Kindle. If anyone out there wants to send a Paperwhite... No! I fucking closed it. A Kindle Paperwhite to me, please email me at this web space. Welcome to the Mouth Noise stream. I thought compound declarations might have been like a class thing, but turns out it's actually really simple. It's just a extension of what we did here. Just as dereferencing a pointer to an int yields an int, dereferencing a pointer to a pointer yields a pointer. To access the underlying object, we must dereference the original pointer twice. Oh, you can do that. Oh, right, okay. So, okay. Oh, that's okay. Right. So if you have a pointer to a pointer that points to a value, you just dereference it twice. Okay, that's fine. That's easy peasy. In fact, this was covered in CS50X. I remember. Very briefly, but I do remember. You may not have a pointer to a reference. Good. You can have a reference to a pointer, but not a pointer to a reference. References aren't objects. Pointers are objects. Okay. It has this example text. But it's hard to do this with no hands-free. Let's just get that out of the way. Prop that up there. I can read that from there. Int and r equals. It's just p there, but yeah, p. It has. Can you stop that? Is there it's like a options and then function names and opening parentheses of argument lists means function names. Set space between parentheses and argument list is empty. Set space between keywords and opening parentheses and control for statements. Insert space for parentheses control. What kind of sick bastard? Pointer reference, align right. Conditional operator. Thank you. Oh my god, thank you. Okay, thank you. Ah! What the fuck is going on? Here you go. So int star and r equals p. It has this in the example code. Sorry, we're not going to compile that because it's well, we don't have a p to begin with. But it's it was talking about how you read this kind of nomenclature, and it says the thing closest to the thing is the most relevant thing to the thing. So when reading this, we find out that it is a pointer because it has the and then we find out that it points to, no, it's a reference. Idiot. It's an R. Why would it be? Anyway, it's a reference because it has the and it is a reference to a pointer, p, and that pointer points to an int value. Very good. That's useful. That's helpful. Even if it's just for reading code, that's helpful. Okay, we're at oh right, yeah. Sorry, I'm just trying to get this so I don't have to move my head on my arms, on my legs, on my face to do the reading, the writing, because it's bad for your posture, really. Exercises. Determine the types and values of each of the following variables. Int star IP, comma, and R equals IP. So IP is a pointer to a int, and R is a reference to the pointer IP. Int I and star IP equals 0. Int I is an int, IP is a null pointer. Int star IP IP2. IP is a pointer to an int, IP2 is an int. Boom! Nailed it. I mean, I don't know if I nailed it, but I'm pretty sure I nailed it. Sometimes constant qualifier. Sometimes we want to define a variable whose value we know cannot be changed. For example, we might have to use a variable referred to the size of a buffer. Okay, cool. So constants was a very big portion of Python, if I do not remember incorrectly. Because they can't be altered, something they take up less memory or something, and because Python, I don't remember, but constants were used often to define things, obviously, that wouldn't be changed, that you knew wouldn't be changed for some reason. Efficiency, legibility, one of the two. We can make a variable unchangeable by defining its variable's type as const. Good. Yes. Const int buff size 512. Cool. So it's basically, it's just a variable, but the variable has const before it, and that means that it's a constant variable, which means it's not variable, would you believe? It is constant. So you can use a const most of the time. One restriction, they only use those operations that cannot change the object. Yeah, that's fine. That's intrinsic to its definition, I believe. A constant converts to a bool the same way as plain ints do. Cool. So that's fine. So they can be read. In any situation where they are only read, you can use them. In any situation where they are going to be written, cannot use them. Good. By default, const objects are local to a file. What? Compile type constants, such as our definition of bus size. Sorry, I skipped a bit, but it was just going over a third time how you cannot assign a new value to a constant. You can take the value of the constant and you can read it and use any operations that would require it to be read. You can use it to compare to see if it is you can use it to compare to get a bool. You can use it as a bool. You can use it as a number. You can copy the value to an int, to a variable that isn't a constant if you need to. So yeah, it's just going to be basically things that you don't need to change. Const object is initialized from a compile time constant, such as our definition of buff size. Constant buff size equals 512, blah blah blah. Compiler will usually replace uses of the variable with its corresponding value during compilation. That is, Compiler will generate code using the value 512 in the place that our code uses buff size. Ah. Oh no. When we define a const with the same name in multiple files, it is as if we had written definitions for separate variables in each file. Oh, sorry. So, okay. So when we are writing a code with more than one file, so source code and header files, the constants are local only to each file, which isn't going to be relevant to us today, I don't believe. That being said, you can use the same name for the const in each file, and each time it can be defined differently or the same. Right. And that's because when you compile it, rather than using the variable name that you use, it uses the value of the const most of the time. That's what it said. Sometimes we have a const variable that we want to share across multiple files, but whose initializer is not a constant expression in this case. We don't want the compiler to generate a separate variable in each file. Instead, we want the const object to behave like other non-const variables. We want to define the const in one file and declare it in the other files that use the object. To define a single instance of const variable, we use the keyword extern on both its definition and declarations. So this is silly. So you have extern const int buff, and then the variable name. Here it's buff size. Right, okay. That's cool. I get it. Which of the following are legal? For those that are illegal, explain why. Const int buff is illegal as it does not have an initialization. Oh wait, actually no, is that not true? It could be legal because ints are initialized to 0, or are they initialized to null? Yeah, it's illegal because there's no initialization, and because they can't be changed, they must be initialized. It would seem that uninitialized ints in this workspace at least are null rather than 0. Int cnt equals 0, that's fine. Const int sz equals cnt. That is fine as long as cnt has already been defined and initialized. Plus plus cnt plus plus sz. No. You cannot increment a constant. Easy peasy. References to const. We combine reference to const. Reference refers to a const type. Like ordinary references, reference to a const cannot be used to change the object, of course, because consts can't be changed. That was, again, part of their raison d'etre. Interesting. Interesting. Initialization references to const. Okay, cool. Combine a reference to const to a non-const object. A literal or more general expression. Okay, so we've got int I equals 42, const int and r1 equals I. Combined a const int and reference to a plain int object, yeah. Const int and r2 equals 42. That's fine. No, what the fuck? R1 doesn't feature in that line of code. But it's fine. Whatever. Const int and r3 equals r1 times 2. That's fine. R3 is a reference to a const. That's fine. Int and R4 equals R times 2. Error, R4 is a plain non-constant reference. I think there's some errata in this. I think someone has gone and inserted errata into this. Just for the funnies, I guess. R4 is a plain non-const reference. I'm going to assume that R is meant to be an R1, and I'm going to assume that R1 previously is meant to be an R2, and then it makes sense. So we have constant R1 equals I, it's fine. Const int R2 equals 42 is fine. Right. Okay, so you can bind a reference to a constant to something that itself is not a constant, which doesn't seem to make any sense to me, but what do I know? And the examples it's giving are that you can bind an int to a reference to an int reference, an int constant reference. You can bind a constant int to a constant int reference. You can bind a constant int reference to some maths which deals with either ints or constants, doesn't matter, because the constants themselves remain unchanged, but you can't bind an int reference to a constant value, it must match. So it's the kind of the degrees of cohesion or whatever. Like a float can hold integer values, but an integer can't hold float values. Well, something like that. The easiest way to understand this difference in initialization rules is to consider what happens when we bind a reference to an object of a different type. What? Double dval equals 3.04, constant int and ri equals dval. Here ri refers to an int. Operations on ri will be integer operations, but dval is a floating point number, not an integer. To ensure that the object which ri is bound is an int, the compiler transforms this code onto something like constant temp equals dval, const int and ri equals temp. In this case, Ri is bound to a temporary object. A temporary object is an unnamed object created by the compiler when it needs to store a result from evaluating an expression. C++ programmers often use the word temporary as an abbreviation for temporary object. Now consider what would happen if this initialization was allowed, but Ri was not const. If Ri wasn't const, Jesus Christ. We could assign that to Ri. Doing so would change the object to which Ri is bound. That object is a temporary, not deval. The programmer who made Ri refer to deval would probably expect that assigning to Ri would change deval. After all, why assign to Ri unless the intent is to change the object to which Ri is bound? Because binding a reference to a temporary is almost surely not what the programmer intended. The language makes it illegal. Okay. I get what not to do, but understanding... So a const reference is a reference that you can use to get the value of what it's referencing. You cannot change the value using a const. A const reference. I see. Okay, cool. Right, yeah, okay, that makes sense. So you can have a pointer to a const as well, and you can have a const pointer to a... What? Oh right, okay, you can have a const pointer to a const, but you can't use a pointer to change the value of a const, and you can't assign a regular pointer to a const. Huh, cool. So you can use pointers. What? Oh, right, okay. So a constant pointer will always point to the same variable, the same memory address, but a constant pointer can be used to change the contents of what it points to if that thing is not itself a const. Okay, that's useful to know, but also incredibly confusing. Top level const. Pointer is an object that point to different object result. We can talk independently about whether a pointer is const and whether the objects to which it can point are const. We use the term top level const to indicate that a pointer itself is a const. When a pointer can point to a const object, refer to that const as a low level const. Which of the following initializations are legal? Explain why. Int I equals -1 and R equals 0. It's fine. We've got an int initialized and a wait. No, no. That's a reference. That's an int reference to 0. You null reference? I don't think so. I don't think so. References have to refer to objects, cannot contain values. Int star const p2 equals and I2. So we've got a pointer constant that points to a variable I2. Seems fine to me. Const int I equals -1 and R equals 0. We've got that and R equals 0 thing again, which is bad. Constint star const const int star const p3 equals and I2. I don't think so. I don't think that'll fly. Right? Let me just scroll up to see if I can find an answer. Okay, maybe that is okay. Const int star const p3. So you've got a constant pointer that will always point to I2. Const int star const p3. I don't think you need the constant. Okay, const double star const pip equals and pi. Pip is a constant pointer to a constant object. Okay, so that is legal. That shows how much I fucking read today. Const int star p1 equals and I2. That's also fine. That's a pointer to a constant int. And that works. That works. Does that work? That's fine. That is fine, yeah. Constant int and constant R2. Nope. Doesn't seem good. Constant int and constant R2. Constant int and scroll back up. No. No, my mistake. What? I think there's a really quick way of doing this, isn't there? That is not good. Reference variable R2 requires an initializer. Oh, does it have one? It does not. There you go. It requires an initializer. You heard it direct from the horse's mouth. It didn't look right to me. But are you saying if that had an initializer, that would be fun? Constant I2 equals I and R equals I. That's fine. That's not fine. That's fine. Oh, that's fine. So we've got a constant int I2, which is equal to I, and we have a reference, a constant int reference to I. I'm assuming I is a constant int or an int at least. That's fine, I think. Explain the following definitions. Identify any that are illegal. Int I, comma, star const CP. In star PL, star const PT, seems fine. Const int IC and R equals IC. It's fine. Const int star const P3. No. No initializer. Const int star P. No initializer. Wait. Oh, pointers don't need initializers because they're objects. They can be reassigned. So they're fine. They're fine. Const int star p is fine. Const int star const p3 is not fine because it's a constant pointer and constants require initialization, right? Constint star const p3. Yeah. There you go. Constant variable p3 requires an initializer. What do you know? No issues. Constant IC and R equals IC. We did that already. Using the variables in the previous exercise, which of the following assignments are legal? Exclaim y. I equals IC. In I, yeah. What is IC? Constant in IC. That's fine. You can copy the value of an int, of a constant int to an int. P1 equals P3. Int star P1, const P2. Nope. P3 is an uninitialized pointer. It threw a hasty fit. P3 isn't a valid thing. I can't do that. P1 and IC. P1 equals IC and IC. Constant in IC. P1. What does P1 point to? Nothing. No pointer. Really? Int star P1 const star const P2. P1 equals and IC. Constant IC. And IC is the memory address. That is fine. Right? That's fine. P3 equals and IC. No, P3 isn't a valid thing. P2 equals P1. No, P2 is a constant. IC equals star P3. IC equals star P3 star. P3 wasn't initialized. It's not a valid. Not valid. Be great if there was just like a swipe to see the answers. I don't know where the answers. I think they might be in a separate book. It might just be at the back of this one. Copying an object. Is fine. New to C++. Yeah, real new. So I was under the impression that you could copy the value of a const to an int. However, it says here when assigning pointers, you have to maintain some cohesion between the top level, the low level constiness. So if the pointers are const, it might be fine, but if the values that the pointers point to aren't const, it might not be fine. So they both have to be const, or you can assign a regular value to a const value. So if you're initializing a const, you can use a regular value, but if you're initializing yeah. I think I may have skimmed this a little bit too quickly. So constant void star pointer itself can't be changed. But the memory it points to can be. Brave man using a void pointer, void star. What? What is that? What is that? It's an underscore. Oh. What's this? Copying an object doesn't change the copied object. As a result, it is immaterial whether the object copied from or copied into is const. What? On the other hand, low-level const is never ignored. When we copy an object, both objects must have the same low-level const qualification, or there must be a conversion between types of the two objects in general. Const void, const underscore pointer, both are const. Yes. Yes, this is mess. Too late to change now. Yeah, it's fun. Don't worry about it. I don't think I'm going to be doing much pointer manipulation. I mean, I will, obviously. C++, that's all you do. But is this common? Do I have to do this every day? Man, what a fucking pain. I'm going to develop games in fucking Python. I mean, no, but seriously. So it says here, do I have a cursor? I have a cursor. We've got an example line of code, star p equals p3. And it says error p3 has low level const, but p doesn't. So, and the definition, I don't know why they dragged these out from the example. What is p3's type? It's a pointer. It's a constant pointer to a constant. It's a const int star const p3. So it's a constant pointer to a constant integer. And p is just a constant. Is just a constant pointer. and it says you can't initialize the value of p, can't perform the assignment since that would need p3 to lose the const. But why? This sound like a stupid question. Like, we're trying to change p, right? We're trying to change. Oh, hang on. It breaks the invariant that p3 is a const. Yes, it does. But one, why? And two, what does that mean? Like, I can just move past this. I can go on to the next chapter, but like, at the start of this, it was saying you can read the value of consts, no problem. It's fine. You can make an int from a const value. A-okay. But now it's like, actually, pointers, no, you can't do that. So the pointer p is a const, right? It's a constant pointer, but it points just to a regular int. And p3 is a constant pointer to a constant int. And I've just realized that there is a star before our p. So would it deal with me for a second now, would it be okay to do something like that, or is the constant part is what it's mad about? On the p3, yeah. I've skipped a page. Where did this page come from? I hate this phone. That is P3's declaration. I hate this phone. Yeah, you need to lose the second const to do the assignment. P3 points to a constant int, P just to an int. Yeah. Constant star and int star are different types as far as the system is concerned. You know what? If I just take it at face value like that and just be like, that's fine, I guess, but I was just, a little bit confused because previously it seemed like you could go back up the chain, but you couldn't come down the chain, as it were. So you obviously can't change a const, but you could set a non-const from a const, and this seems to kind of not agree with that. I don't know. Maybe I'm crazy. Maybe this book is just written in alphabetical order and not in any kind of logical, kind of decent manner from someone to learn from. I gotta stop. I gotta break. I'm gonna move on to the Unreal section, where I can just grab code with my mouse and throw it down, and then look up a helpful YouTube video and tell me what I'm doing in that too. God damn it. Yeah, lol. Lol is correct. Epic struggle. We never got this far into C in CS50. Like, we brushed on consts. No, we didn't. We didn't even... That type of stuff can be confusing. I'm sure we'll get the hang of it one day. We didn't do consts in CS50, but we did pointers, and we did pointers, and references, definitely. Consts I've read about, but it never went into like const pointers because it was definitely Python, and you're not allowed to touch pointers and references in Python. No int star star star. Yeah, int star 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 star. Yeah, absolutely int star star star. That's exactly what. I think that's pretty much where I stopped. Constant expression. Literal is a constant expression. Oh. It's time to stop. It's time to stop. My brain's about to leak out my ears. I have gone for the stated length of time that I'm allowed to learn C for every week. 1 hour. 1 hour of C every week. By the time I die, I will have learned C. But at least I got my Visual Studio working again, even if that was off stream. One day at a time, yeah, one day at a time. One confusing backwards pointer written C++ minefield at a time. I'm starting to see why people want to move to simpler languages, quicker languages to write in. Use references most of the time. Wow. 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 But yeah, as I'm sure you're aware, this book is called the C++ Primer. That is the book that I'm working from. And you're going to be like, don't work from it. But it's cool. I've learned a lot of cool stuff. And today I've learned that references are going to have to be a thing. So I'll probably go back over that next time. But for today, we are done on the C++ segment. I should hit the mic there. Oh my god. It's too late for this kind of stuff. But anyway, thanks for references are what other languages do. What? Some languages. Auto references. But as I was saying, yeah. I hope you had fun. Zombie. Thanks for tuning in, if you tuned in. Thanks for watching the video on demand, if you watched the video on demand. and I'll see you in the next episode. Bye.